Oh, all right. To be tired on a Friday afternoon. Oh, working. Nice one. Okay. Very right. Okay. Right. Can we time? Right. Who's gonna time for it? Okay, Ria. Let's go with 25 minutes. Oh, 25. I'm going to go to the end of it. All right. Everybody, read. Hey, I'm. All right. Hey, so no, hey, right. Okay, come. Okay. So I said, look at that row. Like, it, I mean, isn't that incredible? Okay, so Rosie and this other scumbag here, Alison. I mean, look where they put A in the band. Right, okay. All right, come, I need to concentrate. Let's go. Okay. So, first of all, this is not the section, okay, but you need to understand this in order to do the section. Right. So, if you've got a sequence of numbers, then one, and two, and three, and four, etc., right? That goes on, remember, you've worked with sequences before, you've worked with arithmetic and geometric, etc. Then, if you go add the terms of a sequence, that is then called a series. Okay? The series is the number of the terms of the sequence added together. Kabish, kabosh. Right. So here, I don't know why I left this in, but this is an example of a series, an arithmetic series. Why is it arithmetic? Because you're adding a fixed amount between terms of, yes, the good, okay, numbers. Let's be a bit more specific. What's the difference between 8 and 2? All right. Okay. So now just some terminology. In that particular sequence, series. So this is a series, right? But we still say that term one is equal to 2. Okay? And F, what is the sum? F1 means what are the sum of the first one terms? So in that case, that is also 2. Okay? What's term 2? 8. But what's the sum of the first 2? Look at you.
Then it's 14, 20,
Okay.
20.
Finish it off.
24, 44, 44.
Term 3 is 14, S3 is
24.
term 4 is S4.
44. 44.
Okay. All right. So you just need to know that notation. This is going to be a big, massive section for me to move into. Okay. Of course. Okay. Right. Yes, of course. Right. Not the induction, but the business of theory. Okay. How long does it go? I'm not struggling now. How many minutes? Just keep your time. Okay. Okay. Great. Okay. Right. Then. Okay. Right. Come on. Stay here. Right. Just wait. Okay. Series and sigma notation. Right. So now. You're on stage 1 of my Henry Christmas, right? Stage 2, as my family knows, is when sun comes out, then you guys have trouble. Okay. It's not there yet, but it's coming close. Right. Okay. So sigma, this thing, okay, is a letter of the. Do you have any Greeks here? Okay. So what do you obviously know what that letter of the alphabet is? What is it? Did I say that? Yes, no. It's sigma. Okay, so that letter of the Greek alphabet is sigma. The letter of the Greek alphabet, it's a capital letter. The baby version of sigma is that. Okay, right. But in mathematics, okay, this is an instruction which is saying to you, go add up the terms in the sequence. Okay, so in this particular notation over here, what this means is you have to, the value of each term, that's an individual term. That's term K. That 4K plus 2 is an individual term. Okay? So we say 4K plus 2 is a general term. In other words, what you're going to sub your values of K into. Okay? This bottom number here, in this case, if K is equal to 1, is the first number you're going to sub into K. Okay? We're working, by the way, sigma notation implicitly is sigma notation is only for these things over here have to be integers. Okay. Specifically, actually, they can be integers. They're generally natural numbers. Okay. Right, but they can't be fractions. So what this is telling you is the first term you're going to sub in K is equal to 1 is going to be the first value for K. You sub into that formula over there. Okay. So what is going to be the first term of this particular series? 4 times 1 plus 2, right? That's your first term. That's term 1. Okay? Sigma means what? Go add up all your terms. That's an instruction. Add up all the terms, right? What's the next number? We're going to sub in. The first number we're going to sub in is 1, and the last number, this 5, is the last number I sub in for. These notes, by the way, were written on the side of St. John's School. Right, okay. Most of my work is done on the end of some water polo pool. Right, okay. So then the next number is, that you sub in is 2, right? So the next term is 4 times 2 plus 2. You don't, normally you're not going to show it. This is your turn to work on here. Because what's the number after? So it's saying you sub in all the numbers from 1 to 5. First number I sub in is 1, last number I sub in is 5. But either, it's a tough one. What's the next natural number after 2? Okay, right. So the next number you sub in is 3. Okay. 3 little Indians. What's the next number after 3? Four plus 2. Okay. Right. Okay. And what's the last number you sub in? Okay. Give me an Indian. All right. The last thing I sub in, Alison, is what? Okay. So this series, okay, it says expand and evaluate. So that, just please, that's term 2, that's term 3, that's term 4, That's term 5, right? Okay. So what this whole thing means is you're adding up the following numbers. 4 times 1 is 4 plus 2 is 6. The next one's going to be 10. Next one. Next one. Next one. Good. Okay. By the way, what's the difference between the terms there? 4. What's the coefficient of k? That'll always be the k. It's linear. Okay, but we're not going to, this is not the point of this section. And if you add those up, okay, you get 16, 20, 30, 38, 48, what's 70, eh? So in other words, this guy, the sum from k is equal to 1 to 5 of 4k plus 2 actually represents a single number. It's 7. Okay. So, a reminder. This is what you sub into. This is the first number you sub in. This is the last number you sub in. This instruction means what? Add up. Get to the recalculated there. Okay. Isn't there like an alpha and a sigma? Are we supposed to what? Okay, I'm going to show you. Okay, right. So the good news is, in these ones, the question doesn't say evaluate, it just says expand, right? So you cannot, we're not going to sit here all day writing down 50 terms. Okay. So what is the first term going to be? 5 minus 2 times 2. The next term? 5 minus 2 times 3. I would write down 3 terms. The next term? 5 minus 2 times? Okay. Then you're going to go plus dot, dot, dot. Okay. And the last term is going to be what? 5 minus 2 times? Nice try, Victor. All right. So it ends up being 5 minus 4 is 1. Okay, what's the difference going to be? What's the coefficient of n? -2, right? So the next term will be -1 because 1 minus 2 is -1. Okay. So the series is 1 minus 1 minus 3 plus 5 minus 100 minus of you guys sat in a class and the teacher's IT has gone crazy and you've known how to fix it. But you kept quiet and been like,
Never.
no. Smile. I know, just didn't say that again. No, it's just expand. Okay. Because we're not saying the section is not on sequences and series. Okay, but we have to know the notation to do some of the questions in induction. All right. Go to the next one quickly. Just go to the next two. You don't have to work it out. I just want you to expand them. Seven minus 5 is 2. 7 times 2 is 14 minus 5. And you're adding 7. That's going to be 2 plus 9 plus 16. Plus, and the last term is going to be plus 7n minus 5. We're just going to leave it like that. You're crying. We laugh. When you start to accept this thing, in your head, I was going to picture of these things. So do I want my life to end up like that? Okay. Right, are we happy with these? Yes, they're on a high right now, but wait till tomorrow when they put the shape. Okay. All right, try C. This one here. Okay, so I subbed in 1. 7 minus 5 is 2. Did I sub in? No, you don't have to. I subbed in 2, so what's the next thing? 7 times 2 is 9 minus, 7 times 2 is 14 minus 5 is 9.
Yeah.
Subbed in 3, I get that.
Yeah.
The last term, I have to sub in?
Yeah.
N. Okay. Right. So, Adela, what's the next one going to be? 1. That's going to be 1 squared plus 2 squared plus. In other words, okay. Okay, right. Are we happy with that? Easy peasy, lemon squeezy. Okay. Who was Batman's enemy? The Green Goblin. Also, Penguin. Penguin.
Like kryptonite.
I think you got to be Penguin. Yeah, you are the Penguin. What? One Batman is the enemy was the Penguin.
No.
Okay. All right, let's try the next one. Okay, go to the next one. Go to D, please. Go to D. Now what? Yeah. Okay. Okay, great. Okay. So that, I'm just going to leave it like that for now. Okay, because this is going to be what's important. Okay. You can time it on denominators, be fine. Okay. I'm just going to leave it like that for now. Okay. Because it's more I just want you to understand this notation. Okay. Are we good with that though? Capish? Okay, right. Now just one thing, what is this saying to you, this notation over here? High five yourself, who was that? Okay, you can remove a constant. Okay, if it's a different, it has to be a different letter to what the variable is. That's all that's saying, right? So it's saying if there's a number which is not in terms of I, f of I means it's in terms of I, right? You look absolutely stunned by this, right? Okay, I'm allowed to remove a constant from sigma notation. All I'm saying is this. Can't remove this because this is part of the f of p, right? But I can, because it's times, I can go take out this 2 over here, right? Should be 1 over 2. Please change it. Okay, no, no, so stupid. Right. Okay. This should be, first of all, that should be a 2. This should be a 2. Well, this is why you should go again.
So what can you take out?
Can I take out? Well, I shouldn't be taking out anyone. Okay, I'm a happily married man. Okay, right. That is so late. It is so bad, actually. I'm embarrassed of myself. Right. Right, okay. I can take out this 2 over here. As I was saying, I'm like, that is so bad. Right, okay, so take out that 2. I had it there. Right, okay. So I can remove this constant 2 over there. Can't remove half p because it's a function of p. It's got a variable in it. Capish? Okay. So I end up with 2 sigma a half p from p is equal to 1. So you don't have to do this, but it makes life a bit easier in my opinion. Okay. So when I expand this, it becomes 2 times whatever the series is going to be. What's the expanded series going to be, please, Tweedledee and Tweedledum? In other words, when I expand this.
Yeah. No, I'm getting it. Yeah. 1 over 2.
To that.
Yeah. To the 1.
Good. Plus.
Plus 1 over 2 to the 2.
Right.
Plus 1 over 3. I mean 1 over 2 to the 3. Dot. That's so hard.
1/2 to the my
And
specialty. Yeah. Are we good? How much you walk in the park and think it's break time? Right. Okay. Penguin, how much have we got left? Okay. Right. Okay. Right. So now we get to. Okay. This and I'll need to watch a video if it works. Okay. My technology works. Okay. Right. So, right. Now I need a bit of concentration. Okay. We're now going to have a breakthrough. Okay. Listen. 5 minutes. Give me 5 minutes. Rosemary, to earth. Let's go. Okay. So, would you read for us the rosemary? Okay. Carry on. Can I open hyperlink? No. I'm going to have to go to the actual document. Thinking. All right. So, let's see. All right. So, for those of you who are domino illiterates, okay, right, these are what dominoes are. No, not those.
yeah.
Okay. Okay. And I know it seems weird to be doing this in math, but actually, if you understand how dominoes work, okay, there's no sound. I don't know. The sound's not working. You don't need sound. Okay. Shut up. Just look at it. Okay. Well, I'm so sorry. The sound is not working.
Sure, put it on the computer.
Put it on turn the speaker on if you can. Yeah. Between the two of you, you've got 20 seconds to figure out the sound. Then speak it on there.
Plugged into your computer, sir.
Again, I'm sure you actually don't care about the sound. I think it has to be on Bluetooth. And then start.
So,
We have a class vote. Out of Alison and Rosie, who is the vector of the pair of them?
but you can't.
Who says Alison? It's the instigator. Look at that, Alison. Okay, well, I'm afraid your colleague is not winning.
No, I'm winning.
Come on, video.
It's just taking a while.
What?
Oh, yeah? I'm just that.
Really? Yeah. Yeah.
Well, I haven't heard a single noise yet, so I wouldn't clap.
Hey.
Go back to the beginning. Okay. All right. Wait, it hasn't started yet. This is just an intro. Okay. So these people spend 3 days of their life setting this up. Imagine if I'm mistaking lock one. So this is how induction works.
do actually. I've never watched a domino video until this, and I thought it is strangely satisfying.
I used to try and build it when I had like 6 dogs. And then I don't have to.
Oh. Next day, you keep quiet. Maybe for spiritual hours, you have a domino class. Okay, we did 24 minutes. That is, we get it. What does that actually say?
I think we want to do everything together. I just want to dance. I like that. So leave a follow. I can follow, but the green one's still up. So let's watch the next one, please. It's a 5-minute break, so we show the next one.
Are you on your break?
So the next one, please.
I think it's like 13 minutes.
Yeah, we can see it now.
Right, no. Okay, you're on your break.
So can we even, can we just, search that one. Search that one, please.
Which one?
The 9,000 one.
Where do you see that?
That one.
We're only watching the highlights.
Ja, get faster.
Wait, oh yeah. Okay, we'll start from the beginning. Okay, so induction. Start in the same place. Oh, wait a minute, Phoenix. People like have like time on their hands, man. Set this up.
That's back when this is out. I think it's not one of those.
That's too stressful, I think.
Imagine it didn't work. Oh.
Well, that's Iris.
I reward. This guy's much better than this. Oh my god. No.
We're gonna watch this thing go through all these rows.
Oh my God, this guy is a
Yeah.
Yeah. Yeah. Wow. 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 Wow.
Is that another party?
No, it's the same one that we just was.
The crowd.
It's still going.
Going on in the background.
I don't think it's going to stop.
Did it miss them?
Yeah. That's so bad. That's so bad.
Maybe not.
No, it never.
I think it failed.
It failed. That's so bad. Technically was a $9,000.
No, maybe it's going back there. Didn't fail.
I think it failed and fixed stuff. Yeah. Oh my God. Videographer really got it. I like the sound. Oh. Oh, it failed. No, I
They took the flask on.
think it's going to come in. So, I think it failed. I think it failed right now.
It failed.
It did fail. No, it's going to come back. Yeah, it's back like that.
Probably doing this in my license.
Wow. Wow. Oh, that was wow. Wow. It failed. The best one. No, just one. You want to try it? Wow.
Yeah, I think that deserves a while. Failed. All right. No, it's still going on. All right. finish. Four. Right, let's go do this. Okay. Right. Come. Right, we've got 10 minutes. 10 minutes, I want to do one from one. Okay, right.
What's favorite?
Yeah.
No.
Right. Okay, can we go? We work. Right, 10 minutes of induction. Okay. So induction, listen. I take 10 minutes of work, and then we're done. Okay. So induction, listen. Okay. It works like dominoes. Okay. So in dominoes, what has to happen? Well, you have to make sure this is the equivalent statement. It's just the way of trying to remember the process. Okay. You make sure you have to knock over the first domino, right? You have to be able to knock that over. Okay. Okay. Now, okay. In math, what you're going to have to do is prove it's true for n is equal to 1. In other words, we're proving that the first domino can fall. That the statement will be true for n is equal to 1. Right. Thanks. Then, okay. The next thing we do is we assume that we make an assumption that you knock over a random domino. In other words, we assume that whatever we're trying to prove is true for some random natural number. Okay? Proof part of it is this over here. So this is the hard part of it, if you like. This is what we're going to refer to as the actual proof of the thing. And the proof is you say, okay, we prove that if you knock over some domino, the next domino will always have to fall. Okay? And here we're going to prove that if it was true for some number, I don't know that it is, but assuming it is true, will the next one fall? Okay? We prove that the next one will always fall. Now you're kind of combining two things. You're combining the fact that we have proved it's true for n is equal to 1. So we prove it's true for n is equal to 1. Then separately, we prove that if it's true, we assume that it's true for some random number, then the next domino will always fall. In other words, we prove it's true, then true for n is equal to k plus 1. Now, do you understand the logic? That if you combine this with this, listen, because if you get this, you get induction. Okay. We prove that the first one can be knocked over. That's true. Okay. We prove that if one domino falls over, the next one will always fall over. What does that do? If you combine this side over here, you combine this side with this side, what does it mean? prove, it's all written down there. Prove that if it's true for n is equal to k, then it's true for n is equal to k plus 1. So basically, there's two parts to this proof. First of all, it's this part over here. That it's true for the first domino, that the first domino can fall. The second part, if you like, is those two things together. Okay. That if you knock over one, the next one will always fall, right? If you combine that yellow and that blue bit over there, what does it mean? Well, it means it must be true for all the natural numbers then. Why? Because we've shown that you can knock over the first domino, right? And we've proved that if a domino falls, the next one will always fall. If you combine those two bits, that bit and this bit, it means every single domino will fall over. Okay, you can prove those two bits, that the first one will fall over, in other words, true for n is equal to 1. And we prove that if we assume that one falls over, the next will always fall over. You combine those two bits, all of them must fall over. Why? Because we proved the first one can fall, and we proved that if one falls, the next will always fall. That means that if the first falls, the second will fall, the third will fall, the fourth will fall. So we proved the proof for all natural numbers. Okay. Yes, well, I'm going to teach. Okay. Yeah, you can have a problem. I don't know. I'll go, Brandon.